My name is Muhammad Aiman bin ELIAS. My metric number is 20208 459 and 28.
My name is KHAIRUNNISA AMRINA binti AZLAN. My metric number is 2020477676.
My name is ARFAN bin AHMAD ASARI. My matrix number is 2020494426.
My name is NADHIRAH binti BAZRI and my matric number is 2020843016.
Alhamdulillah, in the name of Allah, the most beneficent and merciful, who gave us strength and knowledge to complete this MAT183 assignment on time. This assignment is impossible to be done without the amazing cooperation and effort of all our group members. Besides that, big thanks we address to our lecturer for their guidance and willingness to help us in what we are lacking when completing this assignment, and surely for teaching us this subject on the second semester. On the other hand, thanks to our beloved group members that always stick together and also work hard to produce a good assignment. Hope that all the effort will give us a lot of benefits and a very excellent results. Last but not least, we are extremely grateful to our parents for their love, prayers, caring and sacrifice for educating and preparing us for our future.
First and foremost, what is differentiation? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. It is a process of deriving f'(x) from fx. f'(x) is called derived function or derivative of fx. Moving on, differentiation allows us to find rate of change. One of the applications of differentiation in the fundamental theorem of calculus is related rate. Related rate is rate of change associated with two or more related quantities that are changing over time. The objectives are to determine the rate of change of angle between the wall and the ladder, and to calculate the rate of change of the ladder height on the wall when there is a movement at the bottom of the ladder.
Okay, now we are moving to the problem statement. Our problem is a 5-meter long ladder rests against a house on a flat ground. The ladder is moving up when it is being pushed towards the wall at the rate of 0.4 meter per second. Here an animation we provide for you, so it may help you to understand the question. There is a ladder leaning on the wall and it is pushed towards at 0.4 millisecond. That's it. We have two questions about this problem. The first one is calculate how fast is the angle between the top of the ladder and the wall changing when the angle is pi/6 radian. First of all we need to do is we have to list down all the information given from the problem statement. As we can see from the information, the rate of change of the ladder when it is being pushed towards to the wall is 0.4 meter per second, which means the ds over dt is negative 0.4. We put negative signs because the ladder is being pushed, so the sign must be in negative. Next, other information is the length of the ladder, which is 5 meters long. Next, after listing all the information from the question, we should know what the problem is or what question is posed to us. For example, from our question, we need to find the rate of change of the angle between the ladder and the wall. So we can just write it as d theta over dt. Then we have to guess how to get d theta over dt based on the information we list just now. Therefore, we can use chain rule by writing d theta over dx times dx over dt to get d theta over dt. After that, we can move on to the next step to solve this problem.
How to find d theta over dx? So, we know the value of theta and the length of ladder, x, which is pi over 6 and 5 meter respectively. Construct an equation that relates to the quantity of interest. In this case, trigonometry is used since theta equals to x over 5, make x as a topic, which means x equals to 5 sin theta. Do a differentiation with respect to theta by using the equation above. So, dx over d theta equals to 5 cos theta. Back to our original tune, which to find d theta over dx, since we has dx over d theta, simply change the equation to complete d theta over dx, which means d theta over dx equals to 1 over 5 cos theta. The last step is we need to find the d theta over dt. The formula to find the d theta over dt had been given on the second step. So, we just replace the information into the formula, which is d theta over dt equals to negative 0.4 multiplied by bracket 1 over 5 cos theta. However, we need to replace the theta to pi over 6 as the information given. So, d theta over dt equals to negative 0.4 multiplied by bracket 1 over 5 cos bracket pi over 6. The final answer of d theta over dt is equals to negative 0.08 radian per second.
For question B, we have to calculate the rate of change of the ladder height on the wall if the bottom of ladder is 400 cm away from the wall.
Step 1. Firstly, list down all the information given from the problem statement. You can use the same information given as in the first question, which is the rate of change when the ladder is moving up when it is being pushed towards the wall at the rate of negative 0.4 meter per second. Then the question gave us distance of ladder to wall, which is 400 cm. Next, we should know what the problem is, which is we need to find the rate of change of the ladder height on the wall. We can simply write it as dy over dt. So using chain rule, we can create equation dy over dt equal to dy over dx times with dx over dt to get the answer. Step 2. Firstly, we need to construct an equation by using Pythagoras theorem. In this case, we are given the length of the ladder, which is 5 meters. Relates the value into the equation. Y square plus with x square equal to 5 square. Next, we need to move y square to the left to make y as a topic. Y square equal to 25 minus with x square. Then, y equal to square root 25 minus with x square. Last, we need to change the equation into power form. Y equal to 25 minus with x square power of 1 over 2.
Then, we need to differentiate the equation of y with respect to x. So, dy over dx equals to 1 over 2 times 25 minus x square to the power of negative 1 over 2 times negative 2x. Simplify it and the answer is dy over dx equals to negative x over square root of 25 minus x square. After that, replace dy over dx as in step 3 into formula form in the first step. Dy over dt equals to negative x over square root of 25 minus x square times negative 0.4. Use the x value given in the question, 400 cm, which is equivalent to 4 meter. Finally, substitute 4 meter into x into the formula and get the final answer dy over dt equals to 8 over 15 meter per second.
The conclusion is The rate of change of the angle between the ladder and the wall after being pushed is negative 0.08 radian per second. In the first case, substitute pi over 6 radian into the derived formula to compute the rate of change between top of the ladder and the wall. For the second question, construct an equation relates to the quantities of interest by using Pythagoras theorem before substitute the given value into the related derived formula.